Hi yo! Today I'm back with the M24 TZ1 counting question. This question is found on paper 1. This is proof that counting principles can go on literally any paper. You have n students on a field trip split into two groups. Group 1 has exactly 3 students and group 2 has more than 3 students. In part A, you are asked to write down the number of ways that the students can be assigned. So, n students, right? You are split into 3 students and n minus 3 students. How many ways can we choose 3 students from n students? Well, n chooses 3. How many students are left? N minus 3. How many ways can we choose n minus 3 students from n minus 3? 1. Therefore, the number of ways that the students can be assigned is n chooses 3. That's the final answer. In part B, 2 of the students ask the teacher not to work in the same group. So, this is group 1. We have 3 slots. Group 2, we have n minus 3 slots. Let's call the 2 students A and B. So, originally, our group of n students consists of A, B, and n minus 2 order students. Correct? How many ways can we choose the students to complete group 1? N minus 2 chooses 2, right? We need to choose 2 students from the remaining n minus 2 students. The remaining n minus 4 students will just take up the remaining space. The role of A and B can also be reversed. So instead of A in group 1 and B in group 2, another scenario would be B in group 1 and A in group 2. And we'll get exactly the same expression in this case. So the equation you have to solve is 2 times n minus 2 chooses 2 is equal to a half of the number of ways that you found in part A. N chooses 3. And now it is just a very long combinatoric equation. Remind yourselves of the definition of combination. N chooses k is equal to n factorial divided by n minus k factorial times k factorial. This formula is in your formula booklet. Therefore, n minus 2 chooses 2 is n minus 2 factorial divided by n minus 4 factorial times 2 factorial. Otherwise, on the right hand side, we have n factorial divided by 3 factorial n minus 3 factorial. N minus 2 factorial divided by n minus 4 factorial. We can roll out one term at a time to simplify this factorial expression. N minus 2 factorial is equal to n minus 2 times n minus 3 times n minus 4 factorial. This will allow us to cancel out the factorials. On the right hand side, same idea. We are going to roll out one term at a time until we hit n minus 3 factorial. So n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 factorial divided by 3 factorial times n minus 3 factorial. And now we can cancel out the factorials. Let's simplify our equations a bit more. 4 divided by 2 factorial, that is 2. Let's multiply both sides by 3 factorial. So 12 times n minus 2 times n minus 3 is equal to n times n minus 1 times n minus 2. Isolate one side. Take the n minus 2 out. We're left with n times n minus 1 minus 12 times n minus 3 minus 13n plus 36. Therefore, n can either be 2, 4, or 9. However, n cannot be 2, right? Obviously. And n be 4. No, n also cannot be 4. Why? Because we have 3 students in group 1, that will leave us with 1 student in group 2. And it is explicitly mentioned in the question that group 2 has more than or equal to 3 students. Therefore, n has to be equal to 9. And this is the end of the 6-mark devil question on counting principles.